When installing cables in an open-air cable tray, it is permissible to derate the cable based on the specific conditions. The National Electrical Code, or NEC, provides guidelines for derating cables in open-air environments. You can find the appropriate derating factors in NEC Table B 310.16. This table allows you to adjust the ampacity of the conductors based on the ambient temperature and the number of conductors in the cable tray. Remember, derating is crucial to ensure that the cables do not overheat and cause a fire hazard. Despite the ability to derate the cable due to its open-air installation, the grounding conductor must still be sized according to NEC Section 250.122. This section provides the minimum size requirements for equipment grounding conductors based on the size of the largest ungrounded conductor. The purpose of the grounding conductor is to provide a low impedance path for fault current to return to the source, thereby facilitating the operation of overcurrent protective devices like circuit breakers or fuses. It is crucial to adhere to the NEC 250.122 table to ensure that the grounding conductor can safely handle the maximum available fault current. For the specific scenario you described, using a Houston cable tray rated cable with 3 500 kc male conductors and a number 2 ground conductor is a viable option, provided it meets the requirements of NEC 250.122. The cable should be installed in an open-air cable tray as intended. Always double-check the grounding conductor size against the NEC table to confirm its adequacy for the 1000 amp feed to the screw compressor. Here is a deeper dive into cable derating. Firstly, let's explore the concept of ampacity. Ampacity refers to the maximum current in amps that a conductor can carry continuously under specific conditions of use without exceeding its temperature rating. Several factors influence a cable's ampacity, including the conductor material, insulation type, ambient temperature, and installation method. The NEC provides ampacity tables for various conductor types and sizes under standard conditions. Secondly, consider ambient temperature correction. The ampacity tables in the NEC are based on a specific ambient temperature, typically 30 degrees Celsius or 86 degrees Fahrenheit. If the actual ambient temperature exceeds this value, a correction factor must be applied to reduce the cable's allowable ampacity. The correction factors are provided in the NEC tables and are based on the conductor's insulation type. Thirdly, note conductor bundling and proximity. When multiple conductors are bundled together or installed in close proximity, the heat dissipation capability is reduced. This phenomenon is known as conductor bundling or conductor proximity derating. The NEC requires that the ampacity of conductors be derated when more than 3 current-carrying conductors are installed in a raceway, cable, or directly buried in the earth. The derating factors vary based on the number of conductors and their spacing. Open-air cable trays offer better heat dissipation compared to enclosed raceways, which is why derating factors are generally less severe. Fourthly, think about voltage drop considerations. While derating addresses thermal limitations, it's also essential to consider voltage drop. Voltage drop occurs when the voltage at the load is lower than the voltage at the source due to the impedance of the conductors. Excessive voltage drop can cause equipment malfunction or reduce performance. The NEC recommends limiting voltage drop to no more than 3% for feeders and 5% for branch circuits. To minimize voltage drop, you may need to increase the conductor size beyond what is required for ampacity. Now let's focus on grounding conductor sizing. Grounding conductors play a crucial role in electrical safety by providing a low impedance path for fault current to return to the source. The NEC specifies the minimum size requirements for equipment grounding conductors based on the size of the overcurrent protective device protecting the circuit. NEC Section 250.122 provides a table that correlates the size of the ungrounded conductors to the required size of the equipment grounding conductor. The grounding conductor must be sized large enough to safely carry the maximum available fault current without exceeding its temperature rating. If the equipment grounding conductor is installed in a raceway or cable with the circuit conductors, it must be made of copper or aluminum. If the equipment grounding conductor is installed separately from the circuit conductors, it must meet additional requirements specified in the NEC. For instance, if the equipment grounding conductor is run along the exterior of a building, it must be protected from physical damage. The NEC also addresses the use of flexible metal conduit or liquid-type flexible metal conduit as equipment grounding conductors. These types of conduits are permitted to be used as equipment grounding conductors under specific conditions, such as when they are used for short runs and are properly terminated. However, it's essential to ensure that the conduit is listed and labeled for grounding purposes. In cases where multiple circuits are installed in the same raceway or cable tray, a single equipment grounding conductor can be used for all the circuits, provided it meets the size requirements for the largest circuit. This is known as a common grounding conductor. However, it's essential to ensure that the connections to the common grounding conductor are properly made and that the conductor is accessible for inspection and maintenance. Let's explore the NEC Section 250.122 requirements, considering the details of the situation. NEC Section 250.122 dictates the size of equipment grounding conductors. The size is determined by the rating or setting of the overcurrent protective device in the circuit. In the described scenario, the overcurrent protective device is a 1200 amp frame breaker with a 1000 amp feed. Therefore, you must size the grounding conductor based on the 1000 amp rating. Consult NEC Table 250.122 to determine the minimum size of the equipment grounding conductor for a 1000 amp overcurrent protective device. For example, according to NEC Table 250.122, for a 1000 amp overcurrent protective device, the minimum size copper equipment grounding conductor required is a number 1/0 AWG. The engineer specified a number 2/0 ground in each conduit, which exceeds this minimum requirement and is acceptable. It's crucial to ensure that the grounding conductors are properly connected to the equipment and to the grounding electrode system. The grounding electrode system provides a connection to earth, which helps to stabilize voltage and provide a path for fault current. The NEC specifies the requirements for grounding electrode systems, including the types of electrodes that are permitted and the methods for connecting them. Common grounding electrodes include ground rods, ground plates, and metal underground water pipes. The grounding electrode system must be properly installed and maintained to ensure its effectiveness. Proper grounding is critical for electrical safety and equipment protection. By following the NEC requirements for grounding conductor sizing and installation, you can help to prevent electrical shock hazards and equipment damage. If you are unsure about any aspect of grounding, it's always best to consult with a qualified electrician. Furthermore, when dealing with large conductors such as 500 kcmil, proper termination techniques are essential. Use appropriately sized lugs and connectors that are listed and labeled for use with a specific conductor type and size. Ensure that the conductors are properly cleaned and prepared before making connections. Apply antioxidant compound to aluminum conductors to prevent corrosion. Tighten the connections to the manufacturer's specified torque using a calibrated torque wrench. This will ensure a reliable and long-lasting connection. Regularly inspect electrical connections to identify and correct any loose or corroded connections. Loose connections can cause excessive heat and arcing, which can lead to equipment failure or fire. Use infrared thermography to detect hot spots in electrical panels and connections. Hot spots indicate areas of high resistance, which can be caused by loose or corroded connections. Address any hot spots promptly to prevent further damage. When working with electrical systems, always follow safe work practices. De-energize the circuit before working on it, if possible. Use lockout/tagout procedures to prevent accidental re-energization of the circuit. Wear appropriate personal protective equipment, such as safety glasses, gloves, and arc-rated clothing. Be aware of the potential hazards associated with electrical work and take steps to mitigate those hazards. Proper planning and preparation are essential for any electrical installation. Before starting the work, review the plans and specifications to ensure that you understand the scope of the project. Identify any potential hazards and develop a plan to address them. Gather all the necessary materials and tools before starting the work. Ensure that you have the proper training and qualifications to perform the work safely and effectively. Electrical work should only be performed by qualified individuals who have the necessary training and experience. Improperly performed electrical work can be dangerous and can lead to serious injury or death. If you are not qualified to perform the work, hire a licensed electrician to do it for you. Remember that the NEC is a comprehensive set of rules and regulations that govern electrical installations. It's essential to stay up to date with the latest version of the NEC and to understand the requirements that apply to your specific project. If you have any questions about the NEC, consult with a qualified electrician or electrical inspector. The NEC is not intended to be a design manual, but rather a set of minimum safety standards. It's always a good idea to exceed the minimum requirements when possible to improve the safety and reliability of your electrical system. For example, you might consider using larger conductors than required by the NEC to reduce voltage drop or to provide additional capacity for future loads. You might also consider using higher quality components and equipment to improve the overall reliability of your system. Regular maintenance is essential for ensuring the continued safe and reliable operation of your electrical system. Perform regular inspections of electrical panels, wiring, and equipment to identify any potential problems. Test ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or RFCIs, to ensure that they are functioning properly. Replace any worn or damaged components promptly. Keep electrical panels clean and free of debris. Following these guidelines will ensure the safe and reliable operation of your electrical system for years to come. Remember that electrical safety is everyone's responsibility. Take the time to learn about electrical hazards and how to prevent them. Follow safe work practices when working with electrical systems. And always consult with a qualified electrician if you have any questions or concerns. Finally, regarding the specific recommendation to use Houston cable tray rated cable, ensure that the cable is indeed rated for tray installation and meets all other applicable requirements for the intended application. Verify that the cable has the appropriate markings and certifications such as UL listing to ensure compliance with industry standards. Using properly rated and certified cable is essential for ensuring the safety and reliability of the electrical system. To summarize, firstly, derate the cable in the open air tray according to NEC Table B 310.16. Secondly, size the grounding conductor according to NEC Section 250.122, using Table 250.122 to determine the minimum size based on the 1000 amp overcurrent protection. Thirdly, use Houston cable tray rated cable with 3500 kc mil conductors and a number 2 ground, ensuring it meets all applicable requirements. Fourthly, ensure proper termination techniques are used for the large conductors. And fifthly, always prioritize electrical safety and consult with qualified professionals when needed. Remember to verify all information with the latest edition of the NEC and local electrical codes.